Hello and welcome to today's lesson. So I am going to be working on calculating empirical formulas today. And so if you are in the chemistry workbook that we have, it is page 61. But according to what year we're at, it may not be page 61. So I'm going to go ahead and start with question number 3. And I just want to do a quick reiteration of the fact that I would strongly suggest that you try the problem on your own and then continue to watch the Edpuzzle, maybe even after you've done a step, then continue the Edpuzzle versus just copying down what I write. Because if you just are copying my steps, you're probably not going to learn anything. Although if you need to, watch the first problem 3 and then again, slowly, progressively, do more on your own. So I'm going to go ahead and get started on 3. We are doing the empirical formula. This is thallium, carbon, and hydrogen and oxygen. So this one actually has 4 that we're working with. So I'm going to try to put it on here. Actually, I think I am going to go ahead and get a piece of paper to write this on because I just write too big to put this all on there. So I'm going to go ahead and get a piece of paper. And let me just get my given written down, and then we can kind of get rid of the book there. So we have 0.463 grams, and this is TL, I believe. Let me make sure it is. Yeah, I think it's TL. That's kind of hard to see. Okay, but I believe that's what it is. Okay, and then the next one is 0.0544 C. Grams. And then my last one is 0.0685 grams of hydrogen. So I've written down my given. So now we can go ahead and get started on that. So I'm just going to slide this on up. So again, remember the very first step after writing down your given is to do your gram to mole conversion. So that's my step 2. So I'm going to go ahead and get everything set up for that conversion. So again, the question becomes, if I have grams of thallium here, what needs to go down here? And again, grams of thallium. And then what goes on the top is always 1 mole. Then I need to go to the periodic table. If you don't know where thallium is at, it is number 81. Number 81. And it's 204.37. Okay. I'm going to go ahead and do carbon the same way. I'll come back and do my calculations all at once. So if I have grams of carbon here, I need grams of carbon there. Carbon is 12.01. And 1 mole of carbon. Okay. And then my last one, if I have grams of hydrogen here, I put grams of hydrogen here. Again, I look at the table and it's 1.008, and that's for 1 mole of hydrogen. Okay. So the next thing that I'm going to do real quick is I'm going to go through and make sure my units cancel. So what's in the numerator here must cancel with what's in the denominator. Numerator, denominator, numerator, denominator. So my units are canceling, so I am left with here, all I have left is moles of thallium. I have just moles of carbon and moles of hydrogen. Now, next thing. I have here 3 significant digits all the way through. So when I do my division, I do only need 3 significant digits. So we're going to put those in our calculator. So there's what I get. You can see if you agree with me or not. So again, I have got my given done. I have gone from grams to moles. Third step is again, which one is the smallest mole? Okay, value. Okay, and so when I look through these, okay, so our next thing that we're going to do is look again for the smallest mole value. So we have 227, 453, 680. And I'm not worrying about because they all have 2 zeros out in front. If they had different number of zeros, I'd worry about that. So 227 is going to be the smallest value. Okay. And so according to space, I think I have enough room here. I'm going to just slide this on over where you can go down underneath. So I am going to, again, remember we take each one of these and divide it by the smallest. So of course this one's going to be 1 because I'm dividing it by itself. Carbon 0.005, again, keep an eye on me, divided by 0.00227. So let's do that. 453 divided by 0.00227. And that one gives me 1.995. So definitely I could go ahead and just call that 2. Is everybody okay with that? 1.995. So when I round it, it's going to round up to 2. Okay. And then this one is 0.00680 divided by 0.00227. And that one again is 2.9955. So that one I'm going to round to 3, and definitely close enough to 3 that I could call it that. Okay. So when I come to write my empirical formula, okay, again, what I was looking for was what values, X, Y, and Z values go here. And I found them to be TL, just 1, so I don't need to put anything there, C2H3, okay? And that would be my final answer, okay? So that would be question number 3, the final answer. So again, let's put that here, divide by smallest. Okay, so again, there's my steps. The given, the gram to mole conversion, identifying the smallest, and then dividing each by the smallest. We get our ratio numbers, and then our ratio numbers become our subscripts. Okay, so that is problem number 3. So let's go on to problem number 5. And again, we're going to just write down all of our givens. So 97.56 grams. Oops, I'm going to slide this all up. Here we go. Of carbon. 4.878 grams of hydrogen. 52.03 grams of oxygen. And 45.53 grams of nitrogen. So again, what becomes our next step to do? Okay. So hopefully you recognize it as a gram to mole conversion. So go ahead and get your gram to mole conversion done. Okay, so I've gone ahead and wrote down my conversion factors on there. So you might just double check to make sure you are in agreement with the conversion factors before you continue on. Make sure you've done your unit cancellations. Again, just double checking this next step to make sure you are in agreement with me and my values. So you might want to take a minute and look through those. Okay, now just a quick reminder, once you find your moles, remember we look to see which is the smallest. In this case, it is the 250, and then we divide each one of these by that value. Now I've gone ahead and divided mine out, and if you'll look at these two are both 1, but these two did not come out to be close to a whole number. They are in fact 2.5, and I could even call this one 1.5. I'm that close. So remember, if it is a 0.5 value, then what we do is we double everything because this is like a half. So I'm going to double this one. It's going to become 5. I'm going to double this one, and it's going to be 3. I'm going to double, and I get 2, and I'm going to, double, and I get 2. So now when I go to write my formula for this one, my empirical formula, I have C5H3O2N2. Okay? Okay, and we're going to go ahead and do number 7 real quick. Okay, so let's go ahead and get started on this one. This one's a little bit different than the other ones. It is still wanting the empirical formula, but it says you had a 300-gram sample and it contained carbon, hydrogen, and oxygen. It is found that 145.946 grams is carbon, 24.3243 grams is hydrogen, and the rest is oxygen. So I guess my question to you is, how would we figure out how much oxygen, whoops, that's paper's running loose, how much oxygen we have? Okay, so hopefully your answer was that you needed to add your carbon and your hydrogen and then subtract from 300 to get your oxygen. And so I've done that, and my answer would be 129.7297. So again, I'm going to go through the exact steps that we've gone through before. Do your mole conversion, and then determine which is the smallest. Okay, let's just do a quick check to make sure that you're on the right track in terms of doing your conversions. Your grams of carbon cancel, your grams of hydrogen, your grams of oxygen all cancel, and now you need to take care of your division. Okay, so you can double check my values. Now, theoretically, here we do have 6 digits going here. This one actually 6 digits here, and this one, because of the subtraction, also had 7, but I went ahead and did 6 on each one of these. Okay, now remember, you do need to divide by the smallest, so go ahead and get that done. Okay, so I've done the division by the smallest, and of course the 8.10810 was the smallest. And here are my values for my ratios. Now, we talked about this already in the last one. Since it is a 0.5, in this case, we are going to need to multiply by 2. So this one is going to be a 3. Now, this one really, I would say, is close enough to already call it a 3, but again, we're multiplying everything by 2. So this one is going to give me a 6. Okay, and then the last one that we have here is a 2, and we're going to multiply, or 1, we're going to multiply it by a 2, and we get 2. So we got 3, 6, and 2. So this empirical formula would be C3H6O2. Okay, and that would be your empirical formula.